So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quant Topic, and I'm Aman, just welcoming you all to a new amazing video in which we are just going to prove this relation down. And believe me, this is going to be the fastest proof. Believe me, yeah, this is very easy, and you can understand very easily about this if you have followed my videos, right? So basically, to prove this down, let's talk about the gamma function, that is gamma of x equals integral from 0 to infinity of t to the x minus 1 e to the negative t dt. And I hope you have watched my gamma function video. I have uploaded this on my YouTube channel. If you want, just check that out. I have proved that down in that video, like this equation. So if you want, please check that out. Okay, now we are considering t equals n u. Let's talk about u sub here, where n belongs to natural numbers, right? So dt is gonna be n times du. So our gamma of x is going to be integral from 0 to infinity. Well, limits ain't gonna change here, so be careful about that. And t to the, well, oh, I'm sorry, it's n times u to the x minus 1 and e to the negative n u and du, right? Okay, and now if we talk about gamma of x, so we can take n outside, because when we talk about this one and if we talk about this one, so after being multiplied, those things are gonna be n only, and this becomes integral from 0 to infinity of u to the x minus 1 e to the negative and u du. Okay, so oh, wait a second, yeah, it's, I'm sorry, it's n to the x. I didn't care about here x. Oh, I'm sorry. Okay, so we are having that kind of result, right? Okay, and now we can just divide both sides with n to the x. So that is gonna be integral from 0 to infinity of u to the x minus 1 e to the negative and u and du. Okay, so yeah, this is also one of the relations which we need, and I have talked about this relation in my recent video, but I haven't proved this down. So here is the proof of this, right? Okay, but not, we are not here to prove that down, but we are here to prove this big relation. Okay, and now we're just going to take both sides the infinite sum as n goes from 1 to infinity of gamma of x n to the x equals the sum as n goes from 1 to infinity of integral from 0 to infinity u to the x minus 1 e to the negative and u du. And since this gamma of x is independent of n, so that is gonna be pulled out. So gamma of x times the sum as n goes from 1 to infinity of 1 over n to the x. And here we are talking about the linearity, so we can just interchange the integral and the summation sign. So that is gonna be integral from 0 to infinity of u to the x minus 1 and integral sum as n goes from 1 to infinity of e to the negative and u and du. Okay, now if we talk about this one, so this is just an infinite, an infinite geometric series, and this evaluates to e to the negative u over 1 minus e to the negative u. So that is gonna give us 1 over u to the, 1 over e to the u minus 1. So we can just plug here 1 over u e to the u minus 1. Well, you can just prove that down by your own. It's easy, because we have learned that like the infinite geometric series is something like a, then ar squared, and actually it's plus, right? So that is, and a over 1 minus r, and r should be less than 1. This is the condition of geometric series, right? Infinite geometric series, and this is one of those kind of things. So that is what we can do that. And since this is, you can just have a look at, this is the gamma of, I'm sorry, the Riemann zeta of x, right? So yeah, so we can replace that over there. So gamma of x times the Riemann zeta of x equals this sum as n goes from 1 to infinity. Oh, I'm sorry, the integral from 0 to infinity of u to the x minus 1 over u e to the u minus 1 du. So yeah, hence we are done with this. uh, um, Riemann zeta of x equals 1 over gamma of x integral from 0 to infinity of u to the x minus 1 over u e to the u minus 1 du. Hence proved, guys. So yeah, that was pretty straightforward, and I'm really sorry I just messed a lot of things in this video, but still um, we have proved this down, and I'm sorry I just said a lot of times sorry in this video. So yeah, let's just keep it short, and just let's meet up in the next video, guys, and thank you so much for watching this video, guys. Goodbye, take care.